Hi students, we want to try out another type of optimization problem, which is about marginal functions. So given the cost function, here it is right here, c of x is equal to 1,750 plus 180x plus 1.8x squared. And we're also given the demand function, p of x is equal to 540. We want to find the production level that will maximize profit. So let's go ahead and we want to find the production level, and we're trying to maximize the profit, which means that we want p of x. We need capital P of x. We need a profit function to actually take the derivative of. Again, remember, when you see maximize or minimize, think derivative. So we can find the profit function. Profit is equal to the revenue function minus the cost function. We're given the cost function, but we don't have the revenue function, but we can find it pretty easily because the revenue function is just going to be the price, which is p of x, that's equal to p, times the quantity that we're making, which is x. So for this problem, our revenue function is 540 times x. Makes sense. The amount of revenue, the amount of money they're going to be bringing in will be the number of items they produce and sell times the price for each item. All right, so now our goal is to come up with this profit function. So we want to compute p of x here. And again, it's going to be my revenue, so 540x, minus my cost. Please understand here, we're subtracting every term in the cost. So 1750 plus 180x plus 1.8x squared. We're subtracting every single one of these terms. So let me start a little bit over so you'll see the whole thing. So I have my 540x, and I'm going to basically distribute that negative or that subtraction to every term that's in the cost function. So we'll have minus 1750 minus 180x minus 1.8x squared. All right. So now what do? We have a couple of like terms here. So we can simplify this function, and we want to write it in decreasing order of our degree. So we'd want to start with negative 1.8x squared, and then 540 minus 180 is going to be a positive 360x, and then minus 1,750. This is our function that we want to take the derivative of so that we can maximize the profit. So let's do that. Our first derivative of this profit function, negative 1.8 times 2 will be negative 3.6x plus 360. Remember, the derivative of the constant is just 0. Let me go ahead and write my profit equation over here so I can now erase because I need the room. That's good. All right. So what are we going to do? We want to maximize the profit, so we want to basically find the critical number. What's the value of x that is going to be at the peak in terms of profit? So we'll set the derivative equal to 0. And let's go ahead and subtract negative, or add negative 3.6x to both sides. So we have 3.6x is equal to 360. Divide both sides by 3.6. And we'll get here that x is equal to 100. So what are we saying here? That the production level will produce 100 items. Too far over. Let me just write it right here. So we know that we want to produce 100 items. What is that profit? Maybe we want to find the profit also. So what do we want to compute here? P of 100. So the profit here, more convenient form, calculate the profit with x 100. So negative 1.8 times 100 squared plus 360 times 100 minus 1,750. And let me bring this up a little bit higher so that way we can finish the problem off. When you calculate this, you'll have that P of 100 is equal to negative 18,000 plus 36,000 minus 1,750. And what this profit will end up being for 100 items produced is a profit of 16,250. You can think of these as an ordered pair. 100 comma 16,250. That's going to be the point on the graph where we know this function will have a maximum. Because again, what did we do? Wanted to maximize the profit. Coming back to our function also, you can see that once again it has a negative leading coefficient. So we know we're going to have a parabola that is downward facing because of that negative sign. So that tells me that, again, we're coming up to a peak in this function, and at that peak, that's where we have our maximum profit. 100 comma 16,250 is the ordered pair, or the coordinate, of that point, which happens to be the vertex of our parabola. I hope this helps you. Bye, students.